few videos, we've built a Bayesian inference engine, explored why maturity scores fall short, and designed an architecture that combines an LLM with a deterministic reasoning. And today we are finally going to put those pieces together. I'll show you how I turn the ChatGPT Codex into an AI agent that interviews the user, generates structured input, and then executes my Python engine automatically. It looks something like this. So we have a question like, it is a fresh assessment state started and the input JSON has been reset. And the first question is multi-factor authentication enforced for all Databricks users. And I said in the beginning that it is a Databricks implementation of the platform that I want to assess. And I can answer with yes, no, implemented, not yet, and so on. I said yes, and it highlighted that it is one of first 25 questions. And the next question is privileged access to Databricks managed through formal process or just Wild West? So it went on and on with certain questions, and you can even interrupt the engine and say that I'll come with this question later, but I wanted to say that I have backups and that they are tested every year. Because of that, the agent was able to pick up that those two controls are implemented, and then just let's persist and still do the assessment even further, the interview, because I answered only for 5 out of 25 controls. But then I said that no, please, let's run the assessment, and it calculated the risk, which was quite high. But you can see how it's split between my existing incidents. So it all fits together, and it didn't hallucinate, which is a nice way. Even better is that I'm pretty confident that if I will rerun this, and we will do that together with you later in this video, the numbers would be exactly the same, because the reasoning is in the Bayesian engine, not in the LLM part. But even after that, we can force the agent to try and do the RAG and say how it can you estimate the risk, for example, of the supply chain compromise outside of my model, but with my implemented controls. So with this, the agent went ahead, and instead of trying to calculate the probability of the incident and all of the risks using the Bayesian network, it tried to do the same calculation, but using web-based search. And in here it estimated that the residual risk is still low to medium with just 10-20% compared to what we have in my model, and that was 11%, I believe, somewhere here when I put all of those in place. And then I wanted to play a little bit of a devil's advocate and ask how to make it 0%. And the honest answer is that, well, you never can have 0%, because something can happen all the time. Sorry for that clicking. And the practical truth is that we can get to as close to 0 as possible, but never hit 0. With that, let's review the architecture yet again. The LLM, it wasn't responsible for calculating the risk, and instead it acted as interface between the user and the Bayesian engine. Basically just an interviewer that you can speak to. And that left one important question. How do we actually implement this interaction? So how this thing works? And the answer is simple. That's where the Codex Skill come in. A skill is a surprisingly simple thing. So if we will go over here, I added the skill MD, and it's basically just a markdown file that explains how to use something. In our case, that I want to call that skill a security assessment runner, and it will conduct an interactive security interview and run my engine, and then it will try to explain the results. How it will work, I have, well, it is quite a long skill, and I would say that usually you want to make it a little bit shorter. There is a lot of repetition in here, but it works. And basically how it works is that the assessment is driven entirely by the expert definition files located under the experts folder, which you remember from my previous implementation of the Bayesian network. Then, based on all of the controls inside of this folder, that's the overall workflow, by the way, over here. So the agent will read all of the controls, then it will convert those technical controls, because if you remember, they are named something like audit login, and that's it. What I want my agent to do, the skill, is to convert that into the human readable interview questions. After that, conduct the interview incrementally. After it will generate the input JSON file, or actually it will generally generate that input JSON file, and it will allow the user to stop at any time and calculate the assessment, and as a final one, to explain the results. Pretty easy. And then I just wanted to make it a little bit easier for the agent to do that. So I gave some examples. So for example, for the MFA, the question could look like, is multi-factor authentication is enforced for all user accounts? And then how to treat user answers, that yes means value 1, implemented is the same, and so on. And through that interview, the agent will generate the input JSON that will look almost like what we had in my scenarios previously, and basically generate that evidence. And after that, it will try, and I wanted it to use, where is it? Here. It will try to use a Python, but I wanted to force and use a virtual environment and install all of the packages instead of globally, just in virtual environment, so I don't want to mess up with my configuration locally. Yeah, that's pretty much it. So you have this explanation how to do things, what to do, and when to do, with a bit of a general behavior over here, that the agent should not invent some random control values, it should not modify the expert definitions, and that the expert definition is a source of truth for the controls. And yeah, after that, just remind the user that they can finish the interview whenever they want, and go on. First, what I wanted to do is let's clean up my virtual environment so it's not there anymore, and on top of that, let's delete the input file and the results file. So all of that is cleaned up, and by the way, the skill file and all of the code base, it lives in the project in the skill, so it is available over here right on from the beginning. Now with it, we can start a new chat in the security assessment project, and I can say use this skill. What it's going to do, it's going to load the skill definition and try to understand what it needs to do. So it's going to parse those instructions and follow the flow. After it worked for a little bit, it initialized the input file as empty and discovered those 25 controls from the expert files that we already saw. And even then, it started with the first question: does the platform have audit login enabled for security relevant activity? So it just says right away with the first control with the audit log, and if we go back to the Visual Studio, we can see that there is indeed an input file being created that we deleted, and at the moment it is empty. It read all of those experts and found an expert with monitoring expert. The first one is audit login. So it decided to play with this one. What we can do next is that we can answer that no, we don't have audit logs. So it recorded that there are no audit logs implemented, and then moved to the next control from the discovered expert. And this one, it would be, does the platform generate security alerts for suspicious or high risk activities? But what we have now in here, if we go to the input, we will see that the audit login control implemented or marked as not implemented. With that, we can continue with the interview and say that alerts are there. Yes, sure. With that, it indeed will add this control in the input as before. And on top of that, it will continue with questions. Let's skip it a little bit, and I will put a couple of controls implemented right out of the bat. So, something like that. I want to explain the CI/CD pipeline for this platform. And the idea is that we have two repositories and two separate pipelines that are triggered automatically with the commits to main branch. In those pipelines, we have unit tests, validation of the code, we have the security scanning and misconfiguration scans. And if everything passes, then the deployment is automatic to dev environment. After that, it is automatic into the test environment, and in test environment it waits and waits for the user approval to deploy to production. And after each of the production runs, it will save the SBOM and maintain those artifacts for audit purposes. Let's see what will happen when we run this explanation. Well, system says that it's a useful chunk of evidence, and the result of this one is that we have pipelines, we have security scanning, we have change management in place, that's right, dependency scanning, yes, SBOMs and signed artifacts, all right. The protection and pipeline isolation are unanswered for now. Well, maybe it needs a bit more explanation because I wanted to highlight that actually that is in place. Let's see what would be the result with the current state. It's always interesting how it always happens with the demo codes and the demos. Well, not always, but sometimes, is that the dependency installation is taking longer than expected. So it is still installing, no errors, and it just taking its sweet time. Finally, dependencies are installed, and now it runs the engine. The assessment is complete, the results are saved to the JSON file, and it explains that the overall risk is quite high, with 71.4, because of all of the evidence collected. Because as you remember, we treat that if some of the controls are not mentioned in the evidence, it means that they are not implemented at all. So basically we have no MFA, we have no network protection, and the system is very wide open for the unauthorized access, for example. Basically it means that you can enter admin as username password and get the SA privileges on this theoretical system. That is the highest incident likelihood, followed by the data exfiltration, service disruption, and the supply chain compromise is at a very nice 25.1%. So it is our strongest suit, while as MFA and access is the least protected area. That's where we should be focusing our attention, right? And on top of that, the model as well checked what are the recommendations, and based on the highest risk, which is unauthorized access, it suggested to implement the privileged access management as a matter of priority to reduce this unauthorized access from 91.7 to 78%, which, well, good thing to start with. Now, what I like about this design is the separation of responsibilities. LLM now responsible for conversation only and to present all of the output in a humanly readable manner, but the Bayesian engine is responsible for reasoning, and that reasoning stays simple and stable. Skill is just for the orchestration, to read whatever user says, map it to the input, run the Python code, and read the output file. That means that I can improve the interview itself without touching the inference engine, basically update the skill and let it run as I want it to be run or sound in a different way, or improve the Bayesian model itself without changing the conversation how that will go. At this point, the proof of concept itself is complete. We have the LLM collecting evidence, a deterministic engine performing inference, and a workflow that connects those two together. The next challenge isn't building the tooling anymore, it's improving the quality of the knowledge behind that assessment. So I'm really looking forward to those next videos where I'm going to start looking at how experts model can be expanded, because right now 25 controls is pretty much nothing, and combine them together and validate and produce more meaningful security assessment. Stay tuned.